Okay, good evening, ladies and gentlemen. This is Engineer Michael. One of you, to be specific, button asked that I should share a complete report on box culvert. So what I've decided to do is now to try to model a simple box culvert from scratch without using the wizard. I'll be using the nodal approach, do my nodes, and then generate the elements, the plates, then proceed and apply loads, the boundary condition, apply loads, and then also design, analyze and design. So I'll just do a simple single box girder of, I think, 4 by 3. It will be more elementary kind of dimension that I'll be doing, but at the end of the day, you just need to follow and see what I've done to reach where I will be. So once you open all other factors constant that you have done, the design, hydrology has done their part, you have done geotechnical, hydrology, environment, road profile, surveyors, everything has been done, and now you have the report as a structural engineer or a CAD engineer. All you need now, and you have your software. So what you do, you open your MIDA Civil, and then from there you go to Neo. Once you open Neo, then what we do normally is, the first step I always say is, first of all, you must know your this thing you can't see it very well, but if you look at this, you will find actually that I have sketched the culvert. Actually, it is a double cell. So you must have to do all this. It's not focusing very well, but you sketch all this, have all your story right, and then once you've done that, then you'll be able now to input the data. I will try to explain and post it later, but let's now proceed and do the right. I will go into my properties, and then materials. I come and add materials. I make sure I go to concrete. Under concrete, I go for a minimum class. Normally for box culvert is class 30 for underground structure, or because of the exposure conditions, quality contents of the soil and water in contact. Normally, I think maybe research has discovered that at least it's good to have a minimum concrete grade of 30. So for that case, I'm adopting cylinder string of 30 and the compressive of 37. So now you apply that, and because box culvert is a rigid member, one component, so I think one grade will be enough. It's not good to split grades. Maybe if you wanted, maybe you could do, but I think let's maintain the grade. Then I go to sections. That one I will close. So when I go to section, I don't think we are going to do any section. We are moving into walls and slabs, or walls and base slabs and top slabs. So I will be into the thickness. So I move to my thickness. Then I add the thickness. So the thickness of the top slab, if I would do, I assume that in 0.4, I make sure I add. This is my point. This thickness could be for my top slab. Then the bottom slab, I could do a 0.5. I then also apply. Then the vertical walls, 0.4 external and 0.3 or 0.25, 0.3. I can then say 0.3. I apply. So these values here, the 1, 2, 3, will actually be for my top and bottom. I can even do the same for my wing walls, and then the bottom slab I can do the same for my apron slab. while this one is for my wing wall, and this the interior. So with that, I'm done with sections, and then I can close. And then when I come to this the tree menu, I can now view that the grade has been put, that has been recorded. I have recorded the thickness, and I've recorded that. Now normally I would save this as materials, so I could go in here, save as, and then this I would go to, okay, I have where I've been saving lecture to my Chambung University guys, and then I create another box culvert 1907 to 07/2024. Then I will do that, and then I save to cell box culvert. Then I save that. Does that mean every time I want to model a box culvert, I will just go into materials, import it, and then start. Now I want to go now to do my model. So I go back to nodos. I said I will be using the nodal approach, not element and planner to extrude. So I just create the XYZ. I create my node, and this is the node created already. So this node created. Again, in my section here, I have sketched for you the span. No, the cross section. And then also this is the road profile, which give you the length. So the length of the culvert is about 24 meters. That's including 14-meter carriageway, 1 meter for where we are putting the guardrail, 4-meter width of the extent of the slope, and then you have the apron length also for 4 meter, and then a typical section. So with that, I'm able now to say, okay, fine, I have gotten this, so let me offset the width, and it is a double cell, which is thickness is 400 millimeter. Then the interior is 4 meters and 300 and 4 meters and 4. So center to center is actually 4. The 150 and 200, that is 350, so 4.35. So I'm able to translate. I make sure I come here. I translate this model in the y coordinate. If I want the length to go from left to right, then I do my 4.35, but twice. So I put 2 times. So you have your node. This node give you the center line of that. Then this same node, I'm now going to translate the same node. That is now the extent of the box culvert, excluding the apron. So I would now do my 0. I go to the x coordinate. It is 24. I do my 24. I apply, and that is what basically I've now defined. I have my, this is the extent of the box. So this box, I can easily now do what we call auto mesh, and then before I auto mesh, I can extend. Okay, no, I think I've made. I need to truncate this is 0 to 24. So this one I remove it. This one is an extra. I think I had extending twice. No, not extending. The translation. So now I have. Let's say this is the bottom. So I offset this. I translate the nodes by in the Z direction, and it's about. It is 400 thickness base, no, 500 thickness base and 500 top. So that means it's 3.5. So 3.5 center to center, I put my 3.5. Positive means I will go up. So once that is done, I can now you can see I have my extent of the center line of the box. So now what I do, I just come in here and I said, can you give me my, so I do the notes, I do chord plus triangle. I want a 0.6 meter division or length. And then since is I'm going to do the wall, let me do the 0.4. as the wall first, and then I do the top plate. So my wall now, the external wall, I just highlight that, this and that, and I say apply. I'm done with the first wall, and then I can go, and I would copy if I want, but let me draw it. But now there's so many ways of skinning a rat. So then the external wall here also is that. I'm done. I apply. I have the two walls of 0.4, but the interior wall I want to say I need 0.3. So I just do that, and then highlight that and apply. I'm done with this wall, but I can also change the colors, and then you are able to have a different color view. Now I want now to do the top slab. Top slab, we agreed it is also going to be 0.4. 0.5, and the bottom. And of top slab is 0.4. So I can just come and highlight the corners because I'm using the nodes to do that. Having done that, I think let me start with the bottom because it might be difficult to. So bottom is 0.5. So I highlight the bottom here, highlight this bottom, highlight my bottom, and I say apply. I'm done with the bottom. So if I look at it, that is the bottom. You are done. Then I want to do so I activate my 0.4, and then I'm done with this corner. I mark this corner of the top, that corner, and I'm done with that. Come in. So we will be done with, oh, little girl, how are you? Yeah, do you want to do engineering?
I'm doing.
You are live.
Am I interrupting?
Yes, exactly. There is busy talking here. Tell me, what's the problem? Okay, so gentlemen, another engineer has come in, but no worry. So this is what. So you have your box. So you can now see you have created a box. So you have created a box here, and you're ready to design it. To put the boundary condition. But we need to also do what they call the wing walls. So once you have your box, and then you are done with that, I want to create now my wing walls. Now this wing wall I created from you need to know that the wing wall has, yeah, you can see slightly. I'm sorry, but I will explain. You have a flaring. You have flaring here. This wing wall is flaring 4 meters at a 45. So basically that is what we are going to do, and I will just highlight. I can only activate the base slab, and then activate on that. That's the only on that. Then I now make sure I extend this, and maybe that I try and translate that in the negative direction at 4 meters. You have done. So once you do this one here, then I now translate this into my in the y direction, but also 4 meters. Same applies here, but in the negative y direction. Please, this is a coordinate approach, so I'm done. I can now even draw for you as quick as possible. Auto, you make sure it is the nodes meshing method, and then quadrilateral and the other one, and we are using a 0.6. So what I could do is to say, now I just connect that trapezoid, and gentlemen, you are done. That is what you would see. Now what do? I just mirror this. I just need to mirror. Mirror in the YZ, but what is the X? Since it is 24, I will do my X at 12. I think I might get. Then make sure you intersect nodes because you are doing a planar. All this has to be done, and you are done. Gentlemen, that is how quick you can do that, and you can easily have a look, and you have that. Now we need the wing wall. How do we do the wing wall? I just have to make sure I also activate. I need to activate the. I need to activate the apron, and in the apron, I just need to make sure the extent of the apron, I raise it by a meter. This one I raise it by a meter. So I just go to translate. The note you translate, if you want to translate a planner or a plate, you come under this panel area where you have all these translations. So there's the notes and then this section of the plate. So I translate, and then it is the Z or the Z, which is 1. If I'm doing it downwards, then it will be negative. So I do that. So if I now bring back that and I put this, I have my 1 here. So because I'm tapering, so what do I need? I come to my auto mesh, and then I do my loading, the collateral, and my 0.6 as the body, and this one I'm also going to say that is 0.4. So my first node here, just link it up here, link it here. I'm done. I can also do this, which are straightforward. Then again I turn. I'm done. Then I do again that side, this side, the 4 corners. It can even be more than it's more than 4 corners. So long as you have highlighted, you are done. This, gentlemen, is as easy as using also the other approach of protruding. I know recently Midas team they were using planner, but here I'm using the node system, and we have the same thing. So once the model is done, what do I need to do? I now need to section have been given, all I need is to create a boundary. So for boundary conditions, I think here there are 2 things. I'm going to use rigid. Rigid connection means all the foundation will be fixed, and then I do a rigid foundation where I fix only the base. If it is a flexible and the rest of it, then I would do, or elastic, then I would do, because of soil structure interaction, you should be able to apply some spring on the sides of the wall and also the base. But for now, we shall do on the side of the wall. Side of the wall, we shall do it. So I just make sure I apply. I do that, remove that, then I highlight, I activate the base. Gentlemen, for soil structure interaction, the spring constant we apply, you can do other formula, you do the foundation design, but what normally we do is, what personally I know that maybe members can also add their voice, is that once you know the bearing pressure, and then you also know the deformation allowable, which we normally adopt as 20, and the bearing pressure, because we are using rock fill, is we believe we shall enhance the capacity. We are not placing it on the weak soil. So once we enhance, then I assume that my bearing capacity is about 300 kPa, and my allowable deflection is about 20 millimeter. Therefore, my subgrade reaction that I need is about 300 divided by 0.02, which is 15,000 kilonewton per cubic meter. So I will be able to apply. So it means I'll be able to apply. Now, because this box culvert is subjected to both lateral force and I will do surface spring, and then I can maybe adopt the horizontal one. I can adopt a lower value, which I think we can still go back to our formula and be able to calculate. And if there's a straightforward way, guys can do, or you can do on the vertical one and you fix on the one corner. So if I do, let me say I do the linear one, so that means here you could do on a compression or tension. So if I do compression vertical, I apply my 15,000 here, and then you apply. Let me shift this here. I will apply this. Let me see, why is it not The direction is here. So we need this direction is the Z downward. So Z negative, Z negative or normal negative, normal negative. So I have this, but on the direction we shall also cross check so that we get quite a lot. We shall also consult. Okay, so I'm done with that. And then that is my, and then I'm able to fix. I'm able to fix the because of lateral effect. Yeah, able to fix. Oh, it has taken many, so I can do that. Then I want to pick, I think, this, and I apply. I hope this will work, because so that is what I think we can do. So once I'm done with the boundary condition, then I would go in for loading. So I first need to test. For testing, let me make sure that normally when you do from first principle, the first thing you need to do is to do the self-weight. My self-weight will be the dead load here to be taken care of by the software. So I will do that. Then when I come here and on a Z, I put -1 and then I add. So when that is done, I'm able to say, please, I saved, I was supposed to save as a model because the first save was material, so I was supposed to save as model, but no worry. So here I can do a run, a quick run to see whether my model is doing well. I need to check to see that the boundary condition given is generating what is reasonable. So once the running is done, I'm able to go to my analysis, and then I go to my reaction. I look for my soil pressure. I want to see that. So what I'm seeing is it has not worked very well. So that means I need to improve, because I needed to see the foundation, the soil pressure layout given properly, but it's more on this side. So what we need to do is I will definitely go and do the second approach of doing it. What's it? So I will highlight my foundations thing here. So my test is it has not given me what I need, the result. So I'm now modifying the subgrade, not subgrade reaction, but foundation support. So I do the boundary condition. I go back to my surface spring, and then since the vertical subgrade reaction was 15, I do my 15. But these I can give them maybe 5,000, but please I'll have to check the calculation. So I apply this. Now when you apply that, I'm able to display and undisplay, and then I run again. So once that is done, I sign off, then I run again. So after running, it has given 0.69 seconds. This is very good. So I go back here, I do results, I go reaction. I want to look at my soil pressure. So you can see the difference. This is now what you are able to see, that this is the pressure you have due to self-weight, and that is the concentration. If you want to view only the foundation, I highlight that, and then I view that and look at the pressure distribution. That is exactly what you look at. You can also look at the legend, and you want to see the value. Actually, your pressure only due to self-weight, you have 34 kilonewton Pascal, kilonewton per square meter. That is the bearing capacity applied now due to self-weight. But now if we add loading, then you will see it building up to a certain point. Now if your bearing capacity design or enhanced with rock fill is up to 300, then that's when you begin to look at, okay, this is going to work. So basically this is what you see. If I look at the reaction as reactions, then I will see how is the shape of my reaction. You can view this, or you can see the reaction, how it is. It is now smaller this side. Let me twist it a bit to see. So the reaction tend to go towards the center, wider that side, and also when you look at it from the side, it is also tend to to be bigger midway. So that is how you look at it from the straight from reaction values, or you look at the soil pressure distribution that gives you that. So that is what we are able to see in the model of the dead load. Now, what do I need to do? I now need to go back and apply other loadings. So to apply the loadings, we need to first develop the loads, or you must generate the load you're going to apply. What are these loads that you're going to apply? So it is very, very important that we must know what you are going to apply. It's not just a matter of rushing and doing something that you think is going to cause trouble. So in that case, we need to know the fill material. In this case, I'm using on a 0.5 the structure itself. I assume that let the structure pass because I wanted to demonstrate how we can also apply the notional lane and then the traffic on the bridge. So that is why I make sure I do a lesser thickness, because once you do you can apply the traffic load direct, because it is up to about 1 meter that you now do the distribution factor. So what we do is look at the self weight of the structure. Then the next thing will be the fill material, which in this case is about 0.5, and then later we shall look at the hydrostatic pressure, the lateral pressure on the side of the wall, the surcharge effect from the live load, and then from there I'm not going to include any buoyancy. I'm not going to include internal pressure generated by water, because those are things, if you say internal pressure due to water, it tends to counterbalance the lateral force. So my worst case scenario is when the structure is loaded and there is no water, you have vehicle parked there or traffic are moving, such effect is there, then the structure tend to fail. The external walls and the top and bottom slab will tend to curve in, that without any counterbalancing pressure from water and anything. So basically that is the situation. So my load application will concentrate more on the external. I am very confident that by enhancing the bearing capacity using the rock fill, or I would have to some extent I would have used rubber concrete with bearing capacity almost between 700 and 1000 kPa. This time I'm using the loose rock with well compacted. It's going to create more weight, reduce the uplift pressure, which is buoyancy, and the structure will remain safe at whatever weight it has, because that rock fill has already an advantage by adding weight onto suppressing the buoyancy effect. So I think that is what we would do, and therefore I'm going to quickly use some arbitrary values of load. No, you have to generate. Now if the lateral soil pressure is always generated, we do at rest coefficient, which is about 0.5, 0.6, and so the 0.5 to 0.6, let me adopt 0.5, and then we have our three fill is 500, our wall external top to bottom is 3.5. No, it is actually 4 meters, and then you have that. So you have a total of 4 meters plus 0.5, that is 4.5. So 4.5 meters. If I am to generate the pressure, first of all, the live load surcharge is basically, if I'm using a HB45 or a compactive roller of 20 kilonewton per meter square as the surcharge, and therefore because of the coefficient of at rest of 0.5, the surcharge uniformly going down would be the 0.5 multiplied by 20, and I get 10 kilonewton per square meter will be my live load surcharge. Then we have we have the hydrostatic pressure, which I am assuming to go full height of the 4 meter, not all the way up there, and therefore it is actually 4 meters multiplied by 10. I would get my 40 kPa at the base, and then I have the lateral pressure due to soil. I'm only taking one, but you would also do when it is saturated and non-saturated. So I'm giving you the 0.5 by my 4 meter height, and by my the 20 meters, let's say 22 kilonewton per cubic meter. So that gives me something to do with 44 kilonewton per square meter at the base. Remember that since it is already filled by 0.5, so at 0.5 this is at 4 meters. So LP at 0.5 will give me a 0.5 by 0.5 by 22. I would get 5.5 as my the first lateral pressure at the top of the culvert. So I will try to demonstrate. I'm going to talk our generator will demonstrate that. So here what I will do now is to come here and try to apply the loading. First of all, I want to apply loading. The first load I want to apply is on the top slab. On the top slab, the load I have is 0.5. The vertical pressure is 0.5 multiplied by 20. Let's say the unit weight is 20. So 0.5 by 20, I would get my 10 kilonewton per square flooded across. So I assume that it is uniform 0.5, though it would be like a trapezoidal, maybe lesser towards the end, but for purposes of demonstration and understanding, I will leave at that. So I make sure that I define my load cases. I have my vertical pressure. That is I come in here, or dead load 1. I will actually call it as the dead DC1, and then I come in here, I look for vertical pressure. Where is my vertical pressure? Earth pressure is here, active. Vertical pressure is here. I make sure I add it. Then my DC2 I would call as now this. I'm done with the vertical pressure, which is the weight of the soil, including whatever dead load, whether it is gut rails or safety gut rail. I have done that. Then I think I need to go to the lateral soil pressure. Lateral soil pressure, that one is very easy here. It is somewhere after such, no? It is here. It is horizontal earth pressure. I would add that. So I have the vertical fill, then I have the pressure. I need the hydrostatic. So my hydrostatic load or pressure. Now it is groundwater pressure. So these are the three. The live load surcharge, no, I'm not going to do that because we are going to apply the traffic direct. So I have that. So now what I do, I come here, loads here, pressure, assign the pressure load, and then I now go in for the first DC1, and then make sure I have my Z here, and this is my negative 10. Now when you have your negative 10, you apply, and I have my dead load there given. As simple as that. Then I go to the site. For site, let me start with the wall. Actually, I can do all this. I do this wall. I do the wall. Okay, someone is calling me. Someone is calling. Got in. Okay, fine. So I have that. I'm going to. It is in the XY direction. So that's lateral soil pressure. The lateral soil pressure is in the Y direction. Please note that it is a trapezoidal, so I have to come and use this approach of hydrostatic pressure. Then light soil is given, and I come down and I make sure it is in the y direction. Then and make sure you indicate the the point, the node. So I think my node is the upper one here. Then the constant is my 10, because that lateral soil pressure, now we calculated it at 5.5, the lateral soil pressure. The lateral soil pressure is 5.5 at the upper part. Then at the lowest, you divide the pressure we calculated of 44, divide by the depth, which is make sure you have your calculator, gentlemen. Calculator is very important. So I have my 4. So by 44 divided, that's 11. So it means every unit is about 11. So I do my 11. So when I do that, I multiply. Now I want you to see that you have your, and you see down is the trapezoidal down. It is narrowing to 5. So that is what you are to you look at. The same thing applies to when you're on this side. You come in here. This time it will be the negative, not the positive. So I have that same. So I just come here and change the 5.5 to be a negative here, and this will be that, and we are done. You can see this one has given you the negative, the what? No, negative. So they are all trapezoidal. No, not trapezoidal. Yeah, trapezoidal, because up is 5.5 and down. So now we do the live load surcharge. What I needed to add is the live load surcharge. Live load surcharge is the LLS, and here it is somewhere down here. Live load impact, no, it is the live load surcharge. You add that and you're done. So I just have to come in here and make sure I have my live load surcharge. This one, that, and since it is live load surcharge and reference is that, it is all through, it is negative 10, and this one is 0 because there's no linear stuff. There we go. I also do same here, and then I will do, this time it is positive. I remove that live load surcharge. There we go. I'm done with live load surcharge. I'm done with lateral pressure. Now I'm left with hydrostatic. I can also undo this, and I make sure. Let me assume that the hydrostatic pressure is also all the way up there. That's for calculation. I could do it midway if you have treated your word very well. So I come in here, my hydrostatic pressure is here. It is that one. This time I'm putting it at 0, and then down is since it is 40 divided by 4, it is 10. So I use my 10. There we go. And apply my hydrostatic pressure here. This time it is negative. Please note the nomenclature and the direction. And there we go. Hydrostatic pressure is done. I'm done with the soil pressure. I'm done with the vertical. I'm done with surcharge. But I need to apply on the wing wall. My wing wall this time is facing in this direction. It's a normal direction. So, but same height. So I do my normal. Let me see if it's going to help. And then I have my, since it's tapering, surcharge effect is minimal. We are more into soil pressure and hydrostatic, and that's the assumption you need to know. It is because it is spreading, it's flaring away from the road. So you have to know that it is minimal for this case. So so the lateral pressure, it is 11, and so that is what we call the soil pressure. Let me see what, and then I apply, and now it has given opposite thing. So I'm going to convert and do this. So the best is to say, okay, fine. What I need to do is to first of all, let me work on the wing wall first, wing wall alone. Then from there I pick this, and I think this. So if I pick this and that, what will happen? Okay, Yes, please. So the lead engineer is back. Okay, so basically, if you look at the pressure, this is all coming and trying to push it towards the apron. So it means that this is how you would apply that. That means for this will be the negative. So I will do my negative this side, and I want to see. I just have to go. So you can see that the pressure is trying to bring to bring the wing walls together. So that is what it is. Now this is for lateral pressure. Then what about for hydrostatic? I invoke this or make it active, and then now for 10 and 4 it was 10, and then it was hydrostatic. I make sure it is activated. We are done with that. Then I highlight this. I do positive. Then you're done. So when you look at it, the direction, the load path direction, they're all okay. Now after doing all the loading, I'm now done with this one. I can now view that, and I can view all the loading I'm doing. So in the tree menu, you can check that you have put all the domain, you have done materials, you have done everything. The weight, actually the weight, self weight is given. Now the vertical weight you can display, and you can see what you have added. You can look at the lateral soil pressure is now everywhere. You can see you are doing it load cases differently, but now you can see everything. Then you have the hydrostatic. Also you have that. Now having done all this loading, gentlemen and ladies, we now can do we now need to move closer. We would actually run analysis if you want. We can try and run analysis, but okay, let's do analysis to see the different implication. After which I need to now to specify how do we, if we are to design a member. Hey, this is already finished. 0.77. Okay, because of the load, you know, when it was only self weight, the speed was 0.69. Now it has added another 8 seconds. So what would be the results of the individual forces, or due to this what we call the, for self weight we have already seen that. Okay, so we have seen this is due to self weight, this is due to vertical load. You can mark the difference. Then this is due to lateral pressure. You can see you see that the implication of different loading onto your box culvert, and then you have the hydrostatic pressure and also the surcharge So basically surcharge, live load surcharge, I'm not seeing it working. Why are you not giving me? Did I put the live load surcharge? Let me see live load. I did not apply live load surcharge. So it is, so that's why when I tried to look at it, it wasn't. So I go back now and I make sure I put live load surcharge. You can apply it, but make sure you know the extent of the wall. This is the wall extent. This is the wall extent in line with the traffic. The center line of the traffic could be here, and then you have your 5 meter, 5 meter, 10. So the surcharge would be the middle, concentrating within what would you call it, within the carriageway. My carriageway, I could, for this particular things, I can quickly say, okay, from the age 14, I know that at 12, this is 12. So this is the point where I need, if I have a 14-meter road, from this point of 12, I need to deduct 7. So I go to 5, 4.8, this 5, around there. Then from 12, and then so I go to 19. So where is my 19? 18, about 18.6, and about 19. So that is what I would pick as the road extent. So arbitrarily, of course, when you're doing that thing, you need to be accurate. So I would say, okay, how much have I left here? It is 1, 2, 3, 4, 4.5. So I also do 1, 2, 3, 4. Also, that would be my so that would be the area I would make sure I apply my, so this side wall here is what I would do to apply the surcharge. I would come in here, loads, then I could still do my area load if I want, because surcharge is uniform. Then I would just come and make sure live load surcharge, and it is in the Y direction, and it is actually 10. I apply. Then I do the same here, but this time a negative value of 10, and I will be done with my surcharge. So we are done with surcharge. I can now do, so you can see the load, surcharge load is concentrating where you have the right down the carriageway. So that is what you need to do, gentlemen. So if I run my software, I want to see the implication of my surcharge onto the foundation pressure. So I will be able to view, I go to my soil pressure, and then I go to my surcharge. That was the only pending thing, and then I view, that is how the surcharge can affect my foundation. This is, you see the concentration, this is the surcharge effect. This is only when you are dealing with soil pressure. I've not gone into moments and the rest. This is just demonstration. So I think because of time, let me try to limit at this, then we do the second session and then conclude. So I think basically, in summary, modeling box culvert is more of knowing what needs to be done. You need to understand the section, the sizes, the different loadings. Some loading I'm leaving it now, but when you're following the steps I've adopted using the node approach, you have seen how quick you can generate your box culvert. And so basically you need to stick to at the end, you always, these people who do management said you begin with an end in mind. You begin with an end in mind, so you know where you are going. It's like you have tied a rope and then you are crossing the river. Where the water is pulling you everywhere, you keep looking at where you have tied your string until you reach where you're going. So basically, you need to maintain that artisanship in modeling, and then you follow, and then you come up with what is you think is good. So for now, let me stop here, and then we go into the I think we have done from modeling, we have applied the load. Now the next session, I'm going to now generate the domain plate section, then we run the design, and then from there we I have to go and do for you the traffic loading, then from there we go. So I think the next now will be the traffic load. From traffic load, we do generate the plate for design for bottom, top, slab, and then the wing walls and apron. Then we run the design, do the combination, and we are good to go. So thank you for now. Thank you so much.